a very warm welcome to everybody joining us on our global webinar series today. And today we're actually going to be talking about all things AI and Wi-Fi. And I'm really looking forward to this one because we've got a special guest joining us who is an expert when it comes to Wi-Fi. And I've seen many of his presentations live, so I'm excited for him to share some of his insights with all of us on the webinar today. So let me pass it back actually to you, Dale. You can introduce us.
All right. So first, as Matt mentioned, we have a very special guest today, very knowledgeable in the world of Wi-Fi, Mr. Wes Purvis of Juniper Mist, Director of Product Management. How are you today, Wes?
Oh, very well, Dale. Very well. Happy to be
Good.
here.
Glad to have you here. Then we have marvelous Matt Starling rather, Senior Director of Product Marketing and ECSE. We also have, in a limited capacity today, say Stu's traveling, but wireless Stu Gomez, Global Director of Community and Customer Engagement for Ekahau. And then there's myself, Dale Tyler, Sales Engineer for the Americas with Ekahau.
I like that nickname, Dale. Thank you, marvelous Matt. I'm gonna steal that one for next time. Yeah, and Stu, hopefully he can chime in a little bit in and out whilst he's coming down to land from his trip. He'll be in the background somewhat. So yeah, what are we going to be talking about on today's webinar? Well, first of all, we decided that we wanted to kind of just dive in a little bit around like with the different types of AI. Because when you say AI, are we talking about machine learning, natural language processing? So we want to cover some of those basics. Then I think it'd be good for Ekahau and Mist to talk about how we leverage AI to assist you to make your life easier and automate some of those tasks. Wes is going to give us an update on the current state of 6 gigahertz. I mean, I'm particularly interested because there's a lot going on in Europe and especially in the UK right now. Things that we can do with antennas, external, inbuilt, directional antennas. Lots of good things to cover there. And we are going to do a lot of live demos today, leveraging the power of Ekahau, AI Pro Online, a few things there, and also Mist and show some really cool integrations. So what is AI? I mean, I'm sure we've all heard AI about a billion times just in the last couple of days now, and probably going to show my age here, but when I think about AI, I can't help but not think back to that I Robot movie with Will Smith and thinking, oh gosh, this is what it's going to be like. And you know what? The Tesla bot kind of isn't too far off that, I would say. Does anyone here ever seen that I Robot movie with Will Smith? I mean, did we really think back in what was it 2004 when this film came out that we would actually see something like this not too long after? But in reality, you know, most of the way that I think like AI and in like warehouses, distribution centers are being used, it's more kind of like robots in this kind of scenario, helping move things along, build things, and ultimately we're going to see a much bigger demand on networks with the use of AI and these kind of machines there. iRobot is a new film. Geez, I'm old. Okay. Actually, I think I saw when I was doing some research here, there might be an iRobot 2 coming out, which could be quite interesting as well. Okay, so natural language processing is what powers things like voice assistants. So if I was to say, you know, hey Siri, play some house music, or Alexa, turn off the lights, did I trigger anyone's assistant? Maybe I can see my Siri's is trying to go mad and it's about to put on some.
Mix now playing on Spotify.
I don't know if I don't know if you can hear that in the background or not, but yes, I've managed to get my assistant going. But yes, that's in some of the ways that we can leverage AI and natural language processing, or even, you know, talking to these. I want to say chatbots, but probably not the right term. But I think like ChatGPT, Marvis, Grok, those kind of things. Are there any others out there? What's your preferred method of AI chat bot solution? Do you use ChatGPT, Grok, Marvis? Is it something else? Let us know if I missed anything in the chat there. Then we have computer vision. And the way I like to think about computer vision is kind of giving AI a pair of glasses to be able to see what is going on. And a real cool example, my wife. I like that one in the chat. Grok and ChatGPT, Gemini, Claude. Okay, yeah. I there's some good ones there that I definitely didn't consider. But coming back to the computer vision, so computer vision for me is like giving AI a pair of glasses and being able to actually see what is going on. And if I think of one of the really cool examples of that is I think it's Amazon, but there's some stores in the US where you can walk into the store, and as you walk into the store, the computer vision of the AI recognizes you, ties that to your Amazon account. You can then walk around the store, pick things up, put it in your basket without scanning anything, walk out the store, and then it charges your account based on what you picked up without you having to go to a till or do anything manually paying in the store, which for me, that's pretty cool. Maybe a little bit scary. Has anyone ever been to one of those stores? I've never been to one. I've just seen some things online about them. But yeah, that's how I think of computer vision. Okay, so machine learning is all about finding patterns in data to make smarter decisions that could be anything from, predicting AP locations on a map or even improving some speech recognition. And machine learning is quite a popular thing I would say that Ekahau uses, and maybe Wes will reveal some of the things that Mist does as well with machine learning. Then when it comes to the robotics and automation, they do heavily rely on real-time data and sensor readings, video feeds, coordinating multiple different devices as they're going around. And to keep these devices working and operating smoothly, you really do need to have fast, low latency wireless networks because these things are not connected via cables. These things are moving around and operating freely. So obviously they're going to be connecting over wireless. And Wes, I think you have a little bit of a story that you can tell about a customer that you worked with quite recently with similar type of devices and the importance of the was having a good Wi-Fi network for those machines.
Yeah, we've had there's been this trend of, hey, with newer generations of Wi-Fi, you have more bandwidth capabilities. You can enable, AR, VR type of use cases. And, I've always thought this is kind of like fluff. But, we have customers who actually do it. So with robots on Wi-Fi, just transmitting immense amounts of data, telemetry, from a development standpoint as well as, from day-to-day operations where, we're at even 5 gig is a struggle. So 6 gig has been kind of what has enabled this use case. But it's to support the AI that's, native on that robot.
Yeah. I think ultimately with more and more network devices, AI devices, the need for having a better performing wireless network has never been greater. And take into consideration really here as well is that the management of like QoS. So if you don't implement QoS on your wireless and wired network, there is a real risk that, some of these applications and devices, they're not going to get prioritized. And likelihood is that maybe some non-business critical applications may end up winning the chance to transmit their data over the air and across the network. Okay, cool. Well, I think that was a nice kind of intro into AI. And what I'm going to do now is actually maybe just quickly show you a few things around how Ekahau leverages AI to assist you with your day-to-day Wi-Fi projects using Ekahau. So on the screen, what you can see now is we just put down a few of the different features and applications that we're leveraging some form of AI to automate tasks to ultimately make your lives easier, faster, and more automated so you don't have to do like the laborious tasks. So things like Just Go survey, our autopilot survey, where you can be walking around without having to constantly tap a position on a map to correlate your location. How about things with our AI Pro Online about automatically detecting your walls and drawing areas for you, assisting you with positions to place access points on the floor as well. Lots of other cool things too, even, aligning your floors and drawing out areas and security testing as well. What I'm going to do is actually towards the back end of the webinar, I'm going to pass it to Wes in a second. We're going to actually do some live demos of these features in action so you can see them for yourselves. So Wes, how does Mist leverage some of the AI?
Yeah, that's a good question. And so we've been in this space for a little while now. And for us, as an infrastructure vendor, it's all about the data. So it all starts with the data, and then we can build on top of that. And if you've looked in our product, you'll see, data come in, it gets processed in form of our service level expectations or SLEs. Then we do some crunching on top of that with their data science, and then there's different outputs, from a natural language processing, conversational assistant to our actions dashboard. But this is kind of missed, and ultimately we're trying to build to this self-driving journey. And just to kind of shine a light specifically on what we're doing, from an AI perspective, right? This is why Mist was founded in the first place. So one of the very first things that we did, from a data science perspective, right, was to aid our location technology. So we have a patented antenna array VBLE on our APs, and one of the very first things we did was a path loss learning, using, leveraging machine learning. So based on device type, we can leverage path loss. So if you're familiar with location-based services, often you have to calibrate to the environment, and the machine learning helped with that, eliminate that. From a kind of AI and deep learning perspective, we have many different algorithms and techniques that we use within our product depending on the use case. So two that I'll talk specifically about are reinforcement learning, which powers our radio resource management, and has for many years. And then a newer one for us, which is called Shapley, that we use in our continuous user experience learning. So, just at a high level, AI, and there's different flavors of AI, right? It's not everything is the same. Not everything is AI. It's, there's machine learning, there's different aspects to it. But fundamentally for us, it's, yes, the techniques are important, and the data scientists who can actually, manipulate these algorithms and techniques are super important. But so is the domain expertise, somebody who knows Wi-Fi, somebody who knows networking. Pair those together, also taking in our customers and support tickets. That's where our customer success team comes in. And then ultimately using that to build a cohesive product, using these new techniques that we have available to us. So one of them is what we call reinforcement learning. This is think of it like a closed loop where you have basically a state, and then there's an action and a reward. So you take some action. Let's say I change the channel, or I increase the transmit power, reduce the transmit power. That's the action. Then you have the environment. We monitor the environment, and we feed that back into RRM to understand, is that a good change or a bad change? And in our case, that reward is what gets fed back in is the coverage and capacity and roaming SLEs, if you're familiar with the Mist dashboard. So actually taking in user experience data to make RRM learn the environment and decide, hey, am I making good changes, bad changes, and ultimately change the way it behaves in certain environments. And then another example is this idea of continuous user experience learning, where based on data, there's a prediction and an ability to explain a dominant feature that is contributing to a poor experience. And a feature could be something like, hey, this client is an iPhone, or this client is only capable of 11AX or 11N, or it's on this particular channel, it has high retries. There's a lot of different features that we can use. So we started this about maybe a year and a half ago now. And we first started using Zoom data, right, where we actually have a cloud-to-cloud integration with Zoom and can bring in your actual Zoom calls to do this analysis. We expanded that to Teams as well. And we came out with this application health SLE. This is how we're actually presenting it in the product, where you can see the dominant features. This needs the Zoom and Teams data right now to actually pick out these bad user minutes, bad user experience. But we're moving to a world where we'll do the continuous user experience learning, but without explicit Zoom and Teams data, using what we have learned, basically using the Zoom and Teams data that we have to train the model to get to this point. So just a couple examples of how we're using AI, ML within the product. So this is definitely, I think, a trend within the industry and something that we're leveraging and I think even pioneered within the Wi-Fi industry.
Cool. Wes, someone actually just asked in the Q&A about the reinforcement learning. So since implementing that, have you found that the Mist dashboard and AI has been able to kind of like learn from that quite well to be able to make smarter changes and, let's say it'd maybe change a transmit power to 14 or 16 dBm, or it's kind of like it's using that data to make smarter decisions. Would you say that's the best use case for the reinforcement learning so far?
Yeah, and it's picking the channels as well. Of hey, I've been, maybe I changed this channel, but later in the day I actually had to change it back, right? There's local interference, that came up. So maybe I won't do that again. And
Perfect. Thanks,
kind of
Wes.
it's the reinforcement learning has made it so like if you're familiar with Mist, there's actually very few knobs that we expose for RRM. And that's because of the reinforcement learning, and the system is able to adjust to a wide variety of different site types and environments automatically. All right. So I want to transition over to 6 gigahertz. And do I look a little out of focus?
It was a little bit. Some people were saying you must be using AI for
Yeah.
your autofocus.
Let me, I should turn off the autofocus. Okay. All right. So, transitioning to kind of 6 gigahertz Wi-Fi, which, will kind of be the other part of this webinar. And so, for those of you at WLPC, I showed this graph, but it's a good one, so I'm going to show it again. So if I look across Mist, we've sold a lot of 6 gigahertz capable APs. Actually, that's our dominant AP type these days, as you would expect. And as it turns out, we sell a lot of APs. And if I looked at a year or 2 years ago, it would have been about 30% of people had turned on 6 gig. Now that number is about 50%. So about half and half of the 6 gig capable APs actually have 6 gig enabled. Just kind of a data point. The other interesting piece is around channel widths. So one thing that we've said with 6 gigahertz is in many environments it allows you to go up the channel width, and that's certainly true in the countries with 1200 megahertz of spectrum. So if I look across Mist, these are the kind of our the channel widths that are in use. So about 60% 20 megahertz, 40% 40 megahertz, and 1% 80 megahertz on 5 gig. 40 meg is actually our default. So, we say people never change the defaults. Well, actually, people do, 60%. And then on 6 gig, it gets more interesting. And so this percentage is true for all of the regions around the world. In 6 gig, we actually see a difference depending on the region. So if I look across the world, the average channel width, the dominant channel width is 80 megahertz. And that's also our default. Some people have dropped down to 40 and 20s, but in Europe, where you only have 500 megahertz of spectrum, actually the dominant channel width is 40 megahertz, which is good. People are making good decisions, I think. But yeah, just an interesting data point. And to kind of go a little bit more into 6 gigahertz and what it's done. So if you were to see this, like this is number of clients per AP, you might get a little concerned. Like some of these counts are pretty high, but what 6 gigahertz has done is offload clients from 5 gig. Right, you have an additional radio on the AP, so like we even see times where there's more 6 gig clients on a radio than there are 5 gig clients, and so 2 years ago, 3 years ago, it would have been this column, right? All these clients on a 5 gig radio. Now, there's significant offload of the 6 gig clients, which is really good to see. Another example of 6 gig is this is a large event held 2 years in a row. Over 1 day, looking at 1 day slices here. So in 2023, I think 6 gig adoption was about 10% clients. And so total data transfer was about 3.8 gigs, or sorry, 3.8 terabytes. And the 6 gig contribution to the data transfer was relatively low. But last year, the 6 gig adoption was about 25%, and the 6 gig contribution to the data usage was significantly higher, as well as the total data transferred was significantly higher, almost 7 terabytes. This is the effect that 6 gigahertz, the extra capacity, has on your network. And we've seen this kind of across the board. Another example, here's a university who enabled 6 gigahertz over winter break this past year. They have about 10,000 APs, 60, 70,000 clients. And this is the capacity SLE within Mist. So this looks at what is the percentage of available capacity. The higher number, the better. And so before they turned on 6 gig, they were in the low to mid 90s on average. And then after turning on 6 gig, they picked up probably 6 or 7 percentage points of capacity across that large client and AP base, which is really cool to see. And here's another, here's a large event. This is all the clients on the floor plan. 5 gig is pretty much pegged, almost pegged in this environment, but 6 gig is showing lots of capacity. So that's kind of where we see clients using 6 gig, they're getting on, and there's still a lot of headroom in 6 gig, which is good. But one question that comes up a lot of times is, hey, what about external antennas and 6 gigahertz? There's different rules depending on where you live in the world, which country you live in. And so I want to spend a little bit of time going through 6 gig. Like some vendors have actually moved away completely from 6 gig and 6 gig external antennas on their APs, at least the indoor APs. Some have APs with fixed antennas, but the 2.4 and 5 you can have removable antennas. So just first and foremost, if you haven't seen, this is a really good resource from the Wi-Fi Alliance. It's the countries or regulations enabling 6 gigahertz. And so this is the most up to date. So actually pretty good, very good adoption. It's really been about 4 or 5 years since 6 gig was unlicensed. And again, as a recap, different countries are enabling different swaths of spectrum. So US, we have 1200 megahertz, that's 59 channels. In Europe and much of Asia, it's 500 or 480 megahertz the spectrum, with some countries considering adding the upper 700 megahertz. So just to kind of this is these are the rules, right? So if you look, US, we have 1200 megahertz in this low power indoor mode. And then there's a second mode called standard power, which allows for higher transit powers, as well as indoor-outdoor operation. But this is kind of a US and Canada thing right now. If you look in Europe, UK, Australia, New Zealand, most of the rest of the world, they only have this low power mode, which is in the 480 to 500 megahertz range. UK is considering the upper 6 gig band, as well as CEPT, in broader Europe. But Ofcom is kind of leading the charge here, I would say. But the interesting row here is this external antennas. So if you're in the US and you want to use external antennas with 6 gigahertz, you need standard power. And that means interacting with a frequency coordination service. Many vendors make that seamless. But it requires a frequency coordination service to say, yep, Mr. AP, based on your location, you're allowed to use 6 gig at this transit power, these channels. But in much of the rest of the world, you can actually use the external antennas on 6 gig with no additional rules. So for years, we've sold the Mist AP45E, and you can use that in Europe, in UK, in Australia, in basically everywhere, with 6 gig enabled. No extra rules. And I know that's you'll hear different messages from different vendors, but for Mist, with the AP45E, you are allowed to use external antennas with 6 gig enabled outside of the US.
Okay, thanks for saying that, because that is something that has confused definitely myself a little bit, because I know that you guys have done some deployments in and around UK and Europe using, like you said, the AP45E with technically external antennas, whereas I hear from many other places in the UK and Europe you can't use access points that have detachable external antennas for low power indoor and 6 gigahertz. So I'm a little bit confused.
Yep. I can only speak to what we do.
Okay.
And the just the last point is there are the rules are changing or considering to change, and so in the countries where there's 500 megahertz of spectrum, many of them are in like a consultation or evaluation of can they expand into the remaining 700 megahertz, the upper part of the band. So this is what Ofcom is proposing, where they want to introduce AFC or standard power for the lower 6 gig band so that you can deploy 6 gig outdoors. And I intentionally skipped over very low power mode here, which is another mode, but it's largely not relevant for enterprise Wi-Fi. And then they're proposing deregulating or making the upper part of the 6 gig band unlicensed, or at least shared with some of the mobile operators. So if you're in the upper part of the 6 gig band indoors, okay, go use it. And they actually say they want to get this by the end of the year, right? Which is quite aggressive for a regulatory body in end of 2025. And they're also looking to sort of harmonize, which is the term they use with broader Europe. But the broader Europe timeframe is much slower. Right? There's a regulatory conference in I think 2023, and they're still like they're basically the timeline is let's figure it out by the next one in 2027. So things move slow, but UK is trying to move faster, and hopefully this can become a model for other countries going forward. So with that, Matt, that's my 6 gig update.
Thank you, Wes. Yeah, really, fingers crossed for us in the UK getting the upper 6 gigahertz. That would be nice. I've seen lots of projects where there has been excessive channel interference, even on 6 gigahertz. So getting the upper access to the upper 6 gigahertz will definitely benefit a lot of customers. Alrighty, well, why don't we have a look at what else we've got planned for today's session. Let me go back to sharing my screen, and now you should see my slides. Let me just, I don't know if this happens to anybody else using Zoom, by the way, but every time I share and reshare, it likes to move in different places across my my different screens to try and, I don't know, catch me out. So let's talk about and do some live demos on how Ekahau is leveraging AI and to do some of the things in our application. So first of all, I can't not talk about our Just Go survey mode. If you're not familiar with what this is, basically if you connect your Sidekick or Sidekick 2 to a iOS device that has the LiDAR scanner, which is basically kind of like any pro version of the iPhone or iPad will have this LiDAR scanner. What we can actually do is if you don't have a floor plan of your space, or even if you do have a floor plan and you just want to connect your Sidekick and walk around, the Sidekick will scan and measure everything in Wi-Fi, so across 2, 4, 5, and 6 gigahertz, Wi-Fi and non-Wi-Fi. But what the survey app will do with your iOS device that's got the LiDAR scanner, AR, camera, accelerometer, as you walk around, it will actually be able to understand the environment. You can see that the walls are turning green here, and as you move around, your survey path gets updated automatically, your floor plan is scaled, and then all of the walls are built for you. So as you finish your survey, we can build the floor plan as you walk around. So like for me, this is such an amazing, groundbreaking feature. Not only is it super fun to use, but the amount of times it saved me and saved other people recently when you have been provided inaccurate floor plans or no floor plans at all. And actually, just this Monday gone, someone sent me a example of a Just Go survey that they did of a warehouse. So they had driven to the warehouse to go and do a Wi-Fi survey, an assessment of a network there, and the customer didn't have the floor plans. So they thought they had them. they've turned up on site, not been able to provide them any kind of floor plan. And without this type of survey mode, it would have been really difficult to try and collect any kind of accurate survey data. So I want to show you, here is the results of that Just Go survey mode. Sorry if you see that annoying message there. Hopefully it's gone now. So this is the Just Go survey results of the warehouse. So what you can see here, like from just taking a quick look at this, this is the primary coverage on 5 gigahertz, and this is the secondary coverage on 5 gigahertz. So just from looking at this alone, like straight away, it's quite easy to visually see that they've got issues with coverage in the warehouse. Maybe it's the access points, maybe it's the height of the antennas, maybe it's racks, maybe who knows, like, you know, what is causing this, you know, gaps in coverage. But quite clearly, where you can walk and use the Wi-Fi, you can see that there is issues with coverage that needs to be addressed. And again, like if you didn't have access to this type of survey mode using AI and AR and stuff to build the floor plan for you, you would have been in a situation where you wouldn't have been able to capture this kind of data. So for me, this is so helpful to have access to. And let me show you another visualization. Now we're looking at the channel interference. So it's quite easy again to see from this visualization, clearly they're having some issues with contention, like because anywhere where there's green means there's no channel interference, but anywhere where there's gray means we've got multiple access points sharing the same channel. And again, this is on 5 gigahertz. I don't think there was any 6 gigahertz here, it's just 2.4 and 5. So even on 5 gigahertz, like there's not, I wouldn't say there's a crazy amount of access points here. I'm going to guess just ballpark 20-ish access points. So there is definitely room for improvement with the interference here in terms of channel interference. But what could be causing these access points to, you know, end up sharing the same amount of channels on 5 gigahertz? You could technically have up to, you know, 25 channels that don't overlap with each other. So why do we have channel interference here then? Well, now, even on this floor plan and this survey data from the Just Go survey, we can see that there's an interferer on 5 gigahertz. And if I drill down into one of these data points, you can see all of the, can you see these like narrow little spikes here? So these devices, they are not Wi-Fi, but they operate in the wireless spectrum on 5 gigahertz. And what they're actually doing is they're occupying pretty much all of the Uni 3-band channels on 5 gigahertz. So the access points can hear these non-Wi-Fi devices, and it's causing the access points to not be able to leverage those channels. So there's some interference here that they could go and find, remove and get rid of, and then give them access to additional channels to use on 5 gigahertz and reduce their contention. So if I imagine the scenario back before I joined Ekahau and we didn't have the Just Go feature, if I had turned up to a warehouse and they didn't give me a floor plan, and like they were like, I was thinking, how can I capture some survey data? I would have really struggled. But now you can turn up with just your phone or your iPad, plug in your Psychic, walk around, and you can see all of this information. And now they was able to provide back to the stakeholder, hey, these are some things that you can do to improve your Wi-Fi just from walking around without a floor plan. So for me, I think this is super cool. I don't know about you in the chat or the Q&A. Let me pop that open again. Has anyone here used our Just Go survey mode? Ah, Wes has got his hand up. You might not be able to see him because he's not talking. I think he's just on the speaker mode. But just looking in the chat recently, anyone here? Just Go as a lifesaver. Yes, I honestly I couldn't agree more. And like this data that you see here is from someone sent this to me on Monday, and I was like, this is so cool. I need to show everybody on the webinar today. Okay, so the next way that we are leveraging AI and machine learning to help you is a application called our Optimizer. What Optimizer is an application that runs in the cloud, and once you have done a survey of your environment, you can push that data to Optimizer, and then what Optimizer is going to do is going to automatically analyze your survey results for you and then give you a real nice breakdown of some issues that you're having and some practical step-by-step things that you can do to improve the performance of the network. So why don't we look at this Just Go survey file in Optimizer? So let me jump over here. So this is the warehouse Just Go example, and what you see in Optimizer is we give you these cards, and these cards are different categories or criteria about certain metrics when it comes to Wi-Fi. They could be the things around heat map, like coverage, or how you've configured your network that could be causing you potential issues. And then we give you it in a nice traffic light or red, amber, green visualization, so you can see if it's green, we've got no problems there, but if it's red, then we've got some issues that we want to try and address. If it's amber, this might be a problem, but it's not something necessarily like super in our control, but you should be aware of it. Then simply, if I click on one of these tiles, it brings me down to the floor plan. I can click on the frequency band we want to look at, and now I'm looking at secondary coverage, and I can see the current as is state of the network here. And then we have our recommendation, like we have some best practices on the side. We can then scroll down to the actual recommendations. And if I click on this, it will tell you exactly what like we're recommending you do in terms of changing transmit power, changing channels, changing data rates, etc., etc. But if I slide this slider, you can see how the network is going to look like if you implement those changes. So that was in terms of secondary coverage. If you look at channel interference, you can see that they were suffering from some CCI. If you implement those changes, I can scroll across and I can see the impact of making those changes will have on the network, which is, I think, pretty cool. Okie dokie. What else? Ekahau AI Pro Online. I think this is what actually gets me really excited. We're seeing so many great features go into Ekahau AI Pro Online, and we actually give you 2 different paths that you can take for designing and redesigning your Wi-Fi network. So now you can use measured data of your environment, so survey your network, push that to Ekahau AI Pro Online without drawing any kind of walls or drawing any kind of obstacles. We use AI machine learning to build a digital model of your space where we know how RF propagates in your environment, and you can design and account for changes like moving access points or even swapping access points out for new models and then seeing the impact that's going to have. And of course, we do support, like I always refer to this as the traditional method of predictive modeling, where you would upload a floor plan, set your scale, draw your walls, place your access points, and then see your predictive coverage. So we support that, and we do use AI and machine learning for this method as well. And I'm going to show you that live in a second. So I mentioned this before, the measured data design, we are using AI and machine learning, plus a whole bunch of clever Ekahau scientists and researchers' brains to build a nice simulated version of your space based off measured survey data. We understand how RF propagates, and we know where the attenuation of the different materials you have on site and how that's going to impact the performance of your network and account for changes like swapping our access points or moving them around. And the thing about using this method or model to do your simulations is we found it's actually a lot more accurate. So the measured based design compared to traditional drawing of walls and then manually setting attenuation of your objects, we did some comparisons and we found that using the AI Pro online model of doing the measured data design using our AI machine learning was a lot more accurate. Okay, so why don't we take a look at planning or upgrading or making some changes based off measured survey data? And I want to give a shout out to Mr. Mike Wade. I don't know if he's on the webinar today, but he done us a big favor this week, and he went to the MIST offices and he done a survey of the office and he shared it with us. So this is what we're looking at now, is a survey result of the MIST office. I believe it's in San Francisco. Is that right, Wes? San Jose?
This is Cupertino. Cupertino.
Oh, okay. Anyway,
Yeah.
somewhere in the US. Apologies, my
Yeah.
US geography isn't so great.
The missed office.
The MIST office, yeah. So this is the survey data in Ekahau AI Pro Online, and I've not drawn any walls here. I've not drawn any obstacles or anything like that. And a question that we get asked a lot as well is, can the Psychic 2 survey Wi-Fi 7 access points? And what you can see here is we have Wi-Fi 7 access points from MIST. So you can see the coverage now coming from this access point, and you can see 6 gigahertz and 5 gigahertz, 2.4, whatever you want. So the short answer is yes, Psychic 2 can measure and validate your Wi-Fi 7 access points. The main thing is that it scans across 2, 4, 5, and 6 gigahertz. So MIST have deployed pretty much Wi-Fi 7 access points all throughout their office. There was just a couple of access points down here that are not actually Wi-Fi 7. And what I wanted to show you that you can do with Ekahau AI Pro Online is if I click on this access point, let's say, for example, they want to upgrade this AP to Wi-Fi 7, but maybe they want to relocate it to a different location, perhaps put it inside this meeting room. Traditionally, what I would have to do before is draw all of the walls, all of the windows, all of the attenuation objects, make sure I've configured them accurately, and then I'd be able to simulate and see changes in my environment. But what I can actually do now is I can just grab the access point and move it. I know everyone at home is losing their minds to the house music that Siri is still playing from earlier. But no, this is really cool. So the Ekahau AI Pro Online is using measured survey data from Psychic 2 and AI machine learning to understand how RF propagates in the space, and then you can account for changes and moving things around into different position. We know when there's walls, we know when you've got heavy attenuation objects and things like that. So maybe Wes wants to know what is the coverage going to look like if I swap out, I think these are maybe AP45s, if we swap them for the AP47. So I've just grabbed those 3 access points. And what I can do now is I can just select MIST as the vendor, and I can scroll down. I can take a look at the AP47. And as soon as I select it, you see it's now instantly changed to MIST AP47s. And again, if you want to make some changes, I don't know, like move them around, you can still do that. So the way that a lot of people are using this functionality in Ekahau AI Pro Online right now is that, let's say that you've got a older 2.4 and 5 gigahertz network. It's due for a Wi-Fi refresh and upgrade lifecycle. Wes mentioned earlier how important 6 gigahertz is, so we want to upgrade to 6 gigahertz access points. Even if you survey and measure a 2.4 and 5 only network, you can simulate upgrading to a 6 gigahertz capable access point using this, and you will see the 6 gigahertz heat maps. So that's pretty cool. Let me show you another way now. Let's say that we couldn't get Mike. Let me show you. I want to show you another way that we use AI in Ekahau AI Pro Online. So let's say that we couldn't get Mike to the MIST office, webinar live demo, and we wanted to design Wi-Fi 7, but from scratch, like that traditional methodology of uploading a floor plan, scale, draw your walls and obstacles, etc., etc. So I'm going to design from scratch. I'm going to pick the MIST office. You can see that this is just a PNG file, so no CAD, no PDF, flat PNG file. I'm going to hit open, import the floor plan, and if I needed to now, I can decolor, I can rotate, etc., but this is all good. And I'm going to give it a scale, and Wes assured me that their EBC room door is 0.9 meters in width for a scale. I know everyone thinks I am a terrible Wi-Fi designer now because I keep using doors as my scales, which I know that we shouldn't be doing that, but never mind. I trust Wes. So now that I've finished adding my floors, I can simply hit finish. And now, quick question to everybody in the chat: how long would it take you to manually draw all of these walls, doors, windows, and obstacles for this floor plan? 10 minutes, 20 minutes, 30 minutes, an hour, 2 hours, 1 day, forever? Yeah, okay. An hour, 1 month, 30 minutes, 10 minutes. Okay, some people are pretty fast wall drawers, but okay, even if someone said like 15, 20 minutes too much. But did you notice down here, whilst I was trying to buy myself a little bit of time, we have this wall detection here. So even on a flat PNG file, we use AI to scan the floor plan, and now I can simply hit place walls, and we're going to place the walls of the floor plan, walls on the floor plan, even on a PNG file. And if we inspect this, like, look at how good of a job that this is done. Like, this is crazy to me as well. Like, it's not just done one type of wall type throughout the whole floor plan. It's done brick walls for the outer walls. We've got windows, we've got drywall, we've got doors, and it's done like such a good job. Now, like, don't get me wrong, if I'm being pedantic, which of course I always am, I would come in and I would look at that and go, oh yeah, you know what, I need to fix that a little bit and fix that a little bit. But I could now, oh, and this wall here didn't quite get drawn, but I can come here and I can spend, I don't know, 30 seconds like tidying this up a little bit. I can go into 3D, check out, make sure, you know, this has been kind of built and done properly. And I'm like, yeah, this does look good to me. So if I was to place access points now, you would see coverage would go everywhere and bleed outside of where the actual office is. So again, we can use our area tool, and we have this area detection. So at the moment, you can see this green area across the whole floor plan. So now if I hit place areas, watch what it does. it now snaps to the floor plan too. So again, this is how we're using like AI and some automation to just make your lives a bit faster and a bit easier and save you a bit of manual time. So I'm going to jump actually into this version of the file that I built the other day because we don't yet have attenuation object detection, which is coming soon actually in AI Pro Online. But it's basically the same file, but I've drawn in the desks and stuff because now this looks, I don't know, I think this looks really cool and nice in 3D. So you can see here that we've just got the floor plan. We've not done anything else. So why don't we use our AI auto planner and see how many missed access points we might need to cover this space. So what I can do is I can come in here, search missed. Let me pick the AP47, hit enter and place devices. So now it looks at the coverage, the channels, and it saves the results, and it's placed some access points for us on the map. Brilliant. So that was one way of using the AI auto planner, and I can see the Wi-Fi 7 access points throughout, but I actually just want to do something else very quickly. I'm just going to delete these access points and start again from scratch. And what I want to do is I'm going to come here, and what I want to show you is that you can do this completely manually, or you can do this what I would refer to as semi-automatic and also automatic. So let's say that this is a good suggestion to place this access point in this meeting room. I would place an AP here. So I simply place an access point in this location, but it's also recommended to place one in this lab room. And now like Wes might know, you know what, Matt, we can't get a cable into the lab room or like we can't mount an AP in here. So it doesn't really make sense to place an access point in here. Or actually, let me use this room here as another example. So what will happen if I decide to place an access point in the most important area in the office? When I place it here, the AI will then recalculate and then come up with new suggested locations. So if I don't pick the exact location that we're recommending, it doesn't keep the old position. It will actually look at that and then make recommendations and suggest other ones. So you can do this kind of like manually, automatically, semi-automatically, whatever your preference is. And then again, of course, if you want to then review your space and you can see it in 3D, I never get tired of looking at it. It looks very nice and cool to me. Okay, so that was a couple of ways that we can leverage AI machine learning. And I want to show you a couple of new features in Ekahau as well. So I'm going to jump into a large office demo file that I prepared. And what we've got here that you can see is, again, let me just quickly go into 3D. You can see that we've got everything kind of built out ready. So we've got all of our walls, doors, windows, furniture. And what I really want to pay close attention to is this auditorium. So we've got this auditorium space and I just want to design for here. So what I want to show you actually is if I place a mist AP47 in the auditorium into this location, we can see that the signal strength, it goes pretty far. But we have a new feature available in AI Pro Online actually for capacity planning. So if I switch to visualization now from coverage to capacity, you can see that, it goes red. And if I click on the area, you can see that I've defined some requirements for the amount of devices in this area. So I think they are counted, there's like 200 and something, 250 odd seats. So I put 250 devices, some on 2.4 and the rest across 5 and 6 gigahertz. So at the moment, coverage in the auditorium is fine using the mist AP47, but capacity is failing. So now if maybe if I just copy and paste that, and I need to add a few more access points. Let me add them in over here and then like one over here. Okay, so we've got 4 access points in the auditorium. Let's see if we're now meeting our capacity requirements. And we are, okay? So no, we no longer have any more than 30 devices per radio. So this is now passing and meeting our capacity requirements, but we actually have something else new in Ekahau AI Pro Online called our inspect tool. So I'm going to just go back to the signal strength view and click on the inspect tool. And what that does is if you place this on a map, it's going to show you like the different access points that you could potentially be connected to. So the primary coverage and the secondary coverage. And let me just zoom in a little bit more. And let me just show you again, if I move this, can you see it's no good. I'm getting my finger out to point at my screen, like you guys and girls can see where I'm pointing on my screen. But if you look at the kind of like top left of where my mouse is at the moment, you can see it says connected, and then you can see like at the moment it doesn't like recommend anywhere for. Oh, down the bottom right now, you can see it's like suggesting like as this would be the next best AP to roam to. Well, actually, let's just do a little bit of a simulation that let's say that I come down this hallway and you can see that I'm connected to the AP top left. As I walk in through this door and walk past that access point, at no point as I move around the auditorium does this suggest that a device is going to roam to another AP. So even though technically our capacity is good in here, the likelihood of, from a coverage or client device perspective, of getting it to roam from one access point to another one is quite low. So it's probably most devices will come in and just stay connected to this access point. You're gonna have to rely on the infrastructure. Maybe you can do some client balancing and move things around, but really you want to actually try and control this from an RF perspective. So you might be like, well, Matt, can we not just turn down the power of the access points? And then, okay, well, I hear all of your questions. Let me grab the devices and then let me turn down the transmit power on 5 and 6 to something like 8 and 8. Hit enter. And again, if I just zoom in for everybody, okay, zoom in here. And now look at the coverage. You can still see that this access point is pretty much covering the auditorium like really well. So if again, I go back to the inspect tool and simulate moving it around, at no point does that connected change. It doesn't like roam. So what should we do differently in this scenario is, well, we want to leverage directionality antennas. I said that terribly. We want to use access points that can support directional antennas. And actually Mist have a new access point, the AP47D, which has inbuilt directional antennas. So regardless if you're in Europe, US, or whatever, we can now use an access point that has inbuilt directionality. So I'm going to pick the AP47D, and what I'm going to do is I'm going to place it on the map, and I'm just going to change the transmit power again down a little bit to 8 and 8, hit enter. And then again, let me put in the 4 access points in the same sort of locations. Okay, cool. So now we can see the coverage from these access points. And now if I go back to the inspect tool, and again, just the same, let me just zoom in a bit. And then the same scenarios, like let's say we've walked down that corridor and we come in through here. We're currently connected to this AP in the top left-hand corner. But let's say I want to go in, I go and sit in the bottom right-hand corner. As I walk over here, you can see now I've actually roamed to this access point. Like it's very well, again, this is all theoretical, but like having access points that can control the cell sizes of the radios by antennas, when you're designing for auditoriums, high density, things like that, this is really a good way that you can design to meet your capacity requirements. So a quick demo that I just wanted to show everybody, and also I wanted to show off some of the cool new features that just came out this week that you might have missed, and you can now go and play around with yourselves. Okie dokie. Let me just jump back to some slides because actually the one thing that I want to just jump through and talk about is our integration with Juniper Mist. So you can leverage Ekahau to provision your Juniper Mist dashboard, your floor plans, your AP locations, and some other things. So if you've got a site that's got lots and lots of access points, once you've done a survey, we actually measure and know the real location of those access points. You can push that to the Mist dashboard. And why not do another live demo? But this time, pressure's on Wes for this.
All right.
I've done my live demos for today, so Wes is gonna show us.
All right, so demo guys, here we go.
Yes.
So this is the same survey that our friend Mike Wade performed in the Mist office earlier in the week. So I am in the Ekahau Cloud in Insights, and there is a integrations. So this is taking the survey file that Mike performed, and it will push AP placements into Mist. So I have the true Mist office. We have some APs on a floor plan, but we're going to ignore those for now. There's a bunch of APs not on a floor plan, and you'll see it'll again, we're going to ignore this one. We'll add a new floor plan with and place the APs that we heard in the survey on the floor plan. And so the way to do that is using this integrations button. We're going to export the AP locations. I guess there's also an option for the heat map, but we're going to do the AP locations as well. And I'm going
Don't
to,
forget to not show us your API key, Wes.
yeah, I'm
Yeah,
going to
move it
move
off.
this over just briefly, so nobody tries to do anything funny. I trust you all, of course.
Mhm.
And okay, so I'm in, and so we'll pick the Mist office, and then pick the office site. And then there's only one floor plan, which is the Mist office. And we're going to export the floor plans and AP locations instead of the heat map. Maybe we'll do both. But so now if I go back into Mist, and let's refresh, and you can see the APs have started to get placed. So if I go into live view, there's a second floor plan, Mist office, and boom, there's all of our APs. And
Phew.
it worked. And the nice thing is, there's actually Mike took actually they might not be in yet. Maybe I spoke too soon. Mike actually took pictures when he was doing the survey. And so make it in yet? Not yet.
Yeah, it's coming, maybe.
Okay. Well, there are pictures that get, so from a Mist AP, we support, uploading pictures. You can do this from our Mist AI app, but also while you're doing your Ekahau validation survey, you can take photos. There's a notes button, and you can take the photos. Very convenient. And if you do this, import integration, we'll actually pull in those photos. So here's one of the
Hey.
photos. This. AP near Rakesh. That's how we name our APs.
Where's the AP nearest to you?
When I visit, I'm remote. I usually sit right here.
Okay.
So
Nice.
I guess by reception.
So what was the other option that you had, Wes, to push to the dashboard? I think I saw there. If you get
Um,
back.
oh,
Okay.
okay. I
Now
messed that up.
you're gonna have
I'm
to
gonna have
put
to.
in a
I got too excited.
So there is another option as well with our integration with Juniper Mist that you can actually push something else to the dashboard from the Ekahau data, which Wes can now finally demo to you as well.
So here, there's the heat map. So this is it's a nice leave behind, right? Where when it's all said and done, it's just an image, right? It's just an image with the placements of the access points learned from the survey, as well as the coverage. So just a nice reference, 6 months, a year, 2 years down the road.
Yeah, so you see a snapshot in time of what the actual coverage looked like based on the survey data and the results. So the live demo gods were with us today, Wes. Everything went well. Phew.
Very good. And thank you, Mike Wade, for doing this survey.
Yeah. Big shout out to Mike. I had the pleasure of sitting in his drone deep dive training session recently. That was real nice. Okay, I just wanted to quickly show everybody one last thing, and I'm gonna take over to share. So you might have been thinking about upgrading to Wi-Fi 7 recently and getting those 6 gigahertz capable access points. The Ekahau team, and shout out to Jacob. I know he's here in the background and doesn't like to be called out, but he did a great job working with us and the team to put together an awesome, real practical guide for Wi-Fi 7. So if you're thinking about upgrading, this is a great resource for you to have. You can simply scan the QR code, or I'm sure he's probably dropping the link in the chat right now, and go and download it. It's got lots of real good examples and things you need to think about, and not just thinking about, of course, we think about the Wi-Fi and the wireless side of things, but also thinking about the rest of your network that you need to plan for and account for upgrading to Wi-Fi 7. Wes, was there anything else that you wanted to say, mention before we wrap up the webinar today?
No, I just wanted to thank you for having me.
Oh no, Wes, it was our pleasure. I've been trying to get you on the webinar for a while now to share your expertise. I've always been really impressed with your content I've seen you deliver in other presentations. So I really wanted to get you on our webinar for all of the Ekahau and
Thank you.
joint missed users. So personally, I know I learned a lot, and it was great to have you, Wes. So I know how busy you are. So thank you for taking the time out of your day to join us, and all of our amazing Ekahau webinar guests for being here today. It was really cool to have everyone here and do it back from my home office rather than on the road. So yeah, thank you, Wes. Thank you, Ekahau webinar guests, Stu, Dale, Jacob, and the rest of the Ekahau marketing team for helping put this together. We have another webinar coming up for you next time around challenging environments, which is going to be another cool one. So get yourself signed up nice and early if you don't want to miss that. We have a couple of in-person conferences happening soon. So one in London on April 3rd and one in Germany in May 6th. So if you're in and around those areas and you would like to come by to an in-person Ekahau and our joint partner event, you're more than welcome to come along. We love seeing and meeting you in person as well. So huge thank you to everybody. I look forward to seeing you in the next one, and I really enjoyed today's session. Thank you again, Wes.